In this lecture here, we want to continue talking about curve sketching, and I want to do a very simple trigonometric function for this. And this is really basically a pre-calculus problem, but what I'm going to be doing is applying all the calculus to it. So here's the problem we're going to work on. We're going to look at f of x is equal to minus 2 times cosine of x plus 1, and let's just look on from 0 to 2 pi. So I'm restricting the domain. Okay, so right off the bat, first thing, the domain here, we're just looking on 0 to 2 pi. And so now let's talk about the range, right? So cosine here can go from -1 to 1, right? And so if cosine is 1, you get minus 2 plus 1, which is minus 1. But if cosine is -1, right, you get negative times negative is positive. So you get 2 plus 1 is 3. Okay, so I got my domain, I got my range there, right, when I sketch this. That's really helpful. Now with these trig functions here, we see there's no asymptotes, which is great. So let's find the y-intercept to help me sketch here. Well, that's going to occur at 0, f of 0. Well, that's 0, and then so I put the unit circle over here. So cosine of 0 is 1, so you get minus 2 plus 1. You get minus 1. All right, now let's find the x-intercepts. So you're looking where this, okay, f of x, which is equal to minus 2 cosine of x plus 1, where does it equal 0? So subtract the 1 over, but then divide by -2. You're looking, hey, where does cosine of x equal 1/2? Well, you can see that that is pi over 3 and 5 pi over 3. Okay, so on this interval here, we have two x-intercepts, right? We have the point pi over 3 comma 0, and then we also have the point 5 pi over 3 comma 0. What's another interesting thing is on this interval, you actually have another value where it's the same as the y-intercept, right? So like at 2 pi, if you were to plug 2 pi into this, you also get -1. So that'll help me when I go to graph this at the end, when I graph the endpoint 2 pi. All right, so anyways, we got the intercepts, we know the domain and range. Let's now do the first derivative stuff. Okay. So f of x, f prime of x here is equal to, well, the derivative of 1, it goes away. Derivative of cosine is minus sine, so -2 times minus sine. This just gets me 2 sine of x. So when does, let's see, this f prime of x, which is equal to 2 sine of x equals 0 on this interval from 0 to 2 pi? Well, like, look, when is sine equal to 0? It happens at 0, pi, and then back at 2 pi. All right, so let's hop into this. All right, so we're gonna do our interval. Our first one's gonna go from 0 to pi, and then we're just gonna actually have to go from pi to 2 pi. So let's pick a test value. So I'll pick, I'll pick pi over 2 in here. Here I'll pick 3 pi over 2. And now let's look at sine of f prime of x at the test value. All right, well, you know, what is sine of pi over 2? Well, sine of pi over 2 is 1, so this is positive, and then sine of 3 pi over 2 is negative, so this is negative. So what this tells me then, just by looking at this, okay, this function is increasing on 0 to pi, and then it's decreasing on pi to 2 pi. We also see we have a relative max, right, because it's going from increasing to decreasing. And it's at this pi, so pi f of pi. Well, when you plug in pi, you got to plug it into the original. So cosine of pi is minus 1 times negative 2 gets me 2 plus 1. So this is at the point pi comma 3. All right, we're getting there. We're doing it. So now we just got to do the second derivative stuff. Okay, this is with concavity. It's a little bit more interesting. There's going to be a little bit more analysis here. All right, so the second derivative here. Okay, when you take the derivative of sine, you get cosine. So f double prime of x is equal to 2 cosine of x, and f double prime of x equals 0. All right, well look, so that's going to be at pi over 2 and 3 pi over 2. So we're going to have to start at 0 and go to 2 pi, so it's a little bit more in depth here. So my interval, I'm going to go from 0 to pi over 2. I'm going to go from pi over 2 to 3 pi over 2. And then I'm going to go from 3 pi over 2 to 2 pi. I'm going to get my test value. This one I'll just pick pi over 4. In here I'll pick pi. And, between 3 pi and 2 pi over here, I'll just pick, 5 pi over 3. So now you're looking at the sine of f double prime of x at the test value. All right, so, just like, look, what is cosine? It's just the value of sine of cosine. Cosine at pi over 4 is positive. Cosine at pi is negative. And then cosine at 5 pi over 3 is positive. So we can say that this graph is concave upward from 0 to pi over 2 and from 3 pi over 2 to 2 pi. And then it's concave downward just from, it looks like this pi over 2 to 3 pi over 2. So we have 2 points of inflection, right? Where you change concavity. You have one at pi over 2, so it's pi over 2, comma f of pi over 2. Right, well, when you plug pi over 2 in the original, right, the original was minus 2 cosine of x plus 1, so that's, you get pi over 2, comma 1. And then the next one, you get 3 pi over 2, comma f of 3 pi over 2. You get the same thing. You get 3 pi over 2, comma 1. All right, now we need to put this all together and sketch this trig function here. All right, So when I do this by hand, I'm going to go to the next slide here. So I'm just interested from 0 to 2 pi. So watch how I set this up to sketch this by hand. Okay. So we're sketching the graph of f of x is equal to, and it was minus 2 cosine of x plus 1. So it's got to go down to -1, and then it's got to go up to 3. It's going to start at 0. Here's pi. Here's 2 pi. Okay, if it helps, I'm also going to do this. Here's pi over 2. Here's 3 pi over 2. All right, let's start. Going back for our intercepts. Okay, all the way back. So we have a y-intercept at 0, -1. So here's 0, -1. You get the same thing at 2 pi, so that helps me over here. You have X intercepts here at pi over 3 and 5 pi over 3. All right, so think about where's pi over 3? It's over here. And 5 pi over 3 is right here. Okay. We have points of inflection, or let me go back and do the relative max first. I'm sorry. We have relative max at pi over 3. Excuse me, pi comma 3, not pi over 3. Pi and then at 3. There's my relative max. And then we have points of inflection, right? Points of inflection at pi comma 1 and 3 pi comma 1. Sorry, pi over 2 comma 1, 3 pi divided by 2 comma 1. Misspeaking there, sorry. Which is right there. And right here. Now watch it, just sketch this, okay? Concave upward to concave downward. And then back to concave upward again, right? So it's increasing to pi and then decreasing, and I've used all my points there to help me sketch this. All right, let's check the graphing calculator, see how we did. So it's going to be minus 2 cosine of x plus 1. Yep, and it looks like we've got it there. You can see the first part there, and we've got it. So that's just a very, very simple trig one, just to see how this analysis is done. All right, class, I'll continue this up with one more example, and you'll get, as always, you'll get a chance to practice this come your homework.